All right, John, so the setup of the museum was really fantastic because you could see the interaction between human creativity and manufacturing a product in a more efficient way. You start with the woman using the spindle for spinning, and all she's got that she's working with are basically two hands. Her feet are doing nothing, and there's no efficient energy source. And then the next thing you see is the introduction of the spinning wheel, which both twists and winds the fabric for her in a single step. Then what happens is you get the introduction of the primitive Japanese looms, and what happens now is that you introduce the feet as well as the hands as the innovation into the manufacturing process. Then with Toyota Sakichi, you get this tremendous burst of innovation because he ergonomically improves the process of weaving, but by taking the weaver off of the ground and putting the weaver into an ergonomically more efficient chair. And then the shuttle, which is the basis of the multiple thread loom, for the first time flies by itself back and forth. So the huge innovation here is that for the first time we've taken one hand away, and what we've done is we've separated human work and machine work. And the other innovation is we put the feet to work as a new energy source. And then what you see happening next, as you move to his power loom, is that the hand and the feet don't have to continuously touch the loom anymore. So now we've got more sophisticated separation between human work and machine work. And then the next big innovation occurs with his automatic stop motion machine. And then what you do is, as you move through his different models and you get down to your Type G automatic loom, what we've now got is this enormous separation between the human and the machine, with one human basically just using hands able to oversee the work of 8 different machines. Now, what gets really exciting is that as you move into the more sophisticated machines, two things happen. The wood disappears in the machine, and the machine gets replaced mostly by a metal frame. But the fascinating thing is, even in the power looms, the shuttle technology remains the old shuttle, which is a linear device, until you get to the Nissan water jet machine, where you get the first real breakthrough, and the shuttle turns from being a physical device to an energy device, and water is used to shoot the thread through. And that provides the innovative jump for the next big leap, which is the Toyota Airjet loom, in which the propellant is no longer water, it's a more efficient type of propellant, it becomes the air. Then the thing that really becomes interesting is that the use of andon enters into the machines with the Toyota Airjet loom, in which now we've got a computer console which provides instructions to the machine, and for the first time using the computer you can make variable designs right on the spot with the machine. So that's the next big jump we see. And then finally we look at the fully automated spinning machine, in which all the processes of making thread have been moved into a kind of a U-shaped shell, beginning first with the raw materials, going to carding, drawing the thread, spinning, spooling, mounting the spools, and then finally spinning the multiple threads into bobbins simultaneously. But the thing that I found interesting here was it was the tiny innovations which made the huge difference. And in particular, it was the machine which used Poka-yoke or mistake proofing, so that the winding of the thread stopped whenever the thread broke. And then a really great innovation, the air splicer, which didn't require any human intervention to splice the broken threads back together so that the process could continue. And then I thought a really fascinating feature of the fully automated spinning setup was the fact that there was a self-cleaning device, so that as the machinery worked, a vacuum progressed along with the machinery to pick up any little bits and pieces of material which had fallen on the floor and might potentially harm the machine. So the efficiencies of the machines themselves were maintained during the process of manufacturing itself.